Newton's first law, the first of three, states that a body acted on by no net force moves with constant velocity, which may be zero, and zero acceleration. In other words, a body in motion stays in motion. A body at rest stays at rest. Or, in other words, whatever a thing is currently doing, that is what it is going to continue doing unless you act on it. Right? So unless the body is acted on, if it is going somewhere, it is going to keep going in that same direction. So you have some thing, and it is traveling with some velocity, v, constant velocity. It is going to continue traveling constant velocity to infinity unless it is acted on by another force, right? Unless it's acted on, unless it experiences some acceleration in a different direction. Or, if this little thing, call it an asteroid or what you will, is at rest, unless something acts on it, unless it experiences some acceleration, it is not going to go anywhere. It's just going to sit there. It takes being acted on, it takes experiencing acceleration for it to move. This seems kind of intuitive, but it's really fundamental to our universe. So things to point out here are that it's no net force. So this net is really important. So things can be experiencing a lot of force, but if they all cancel out, then there's no net force. So on our thing here, you might be exerting a force upwards and an equal force downwards. Well, then there's no net force. Net force is equal to 0, and so it is not being acted on. Okay, and so basically what this law comes down to is a property we call inertia. So inertia is the resistance to a change in motion that an object has. So if an object has more resistance to a change in its motion, whether from rest or from some constant velocity it already has, then it has higher inertia. If it has less resistance to change in its motion, if it takes a smaller action to change its motion or to get it going in the first place, then it has lower inertia. And the term that we use to quantify inertia is mass. So inertia we quantify it with the word mass. Mass is a quantification of the amount of inertia that an object possesses. So it's just mass is a way that we can assign a number to this concept of inertia. And this concept inertia is fundamental to our observations of the universe. So this is the reason, inertia is the reason why some things move easier than others. If I have a box that has a very high mass, say 1,000 kilograms, very heavy, and I push it, I exert some force on it this way, say F1, and I exert that same force on this here, which has 1 kilogram, let's say. If I exert that same force, F1, which one will move farther? Well, if you have some big heavy boulder and you try to push that boulder, it's not going to go very far. But if you push just as hard on an empty cardboard box, say, it's going to go farther. And so inertia is the reason for this. And mass is a quantification of inertia. So you've probably seen the tablecloth trick where people pull the tablecloth out from underneath dishware on a table. And you might wonder how exactly that works. Well, inertia is an interesting thing. the more mass something has, the higher inertia, the less it wants to move from its rest state or from its constant motion state. So if you have things on a table, it might you might think that to be able to pull that off, you would want things that are really light, because you want less, pressure down on your tablecloth, so you can pull it out really easily. But this is actually opposite of what you want, because really light things that weigh a small amount, they have less mass, so gravity is pulling down on them with a lesser force. And so they're really easy to get going. They have low inertia. And so low inertia would make the things on the tablecloth want to move. So you have like your wine glasses and your plates and whatnot, and you have your table and your tablecloth. So you want these objects to have a really high amount of inertia. You want really heavy objects. So if they were like solid lead, it would work pretty well, because they would want to stay stationary more than lighter objects. So then you can pull the tablecloth out from the table, and they would have a greater tendency to stay where they are. So in the next video, I've shown a couple demos of inertia to try to get you a more real-world feel of inertia, and also some fun things you can do when you understand inertia. So go ahead and watch those videos and think about inertia and its connection to mass, and this Newton's third law here, which basically states a body in motion wants to stay in motion, or will stay in motion unless acted upon, or a body at rest will stay at rest unless acted upon. Right? All right.